Our next speakers are an interesting pair. One of them, Stanislav, he's really young, but he has several projects behind his back. Yes, let's clap for him, because, yeah. So, I think this is his first time speaking at a conference. And as I said, he has a lot of projects behind his back, mainly focused on desktop, C and C++, but he's using Ruby in some small projects. And Franz, he's also really young. He looks younger. You can ask him about his age later. And the interesting thing about him is that he's automation QA, and he's part of the team that records this conference. And he got introduced to Ruby last year at this conference, which is really cool. And I don't know, maybe it was destiny, because a couple months after, they both work at the same company, and they started using Ruby in their project. And today they're going to tell us about this project, which is a new way to debug CodeTracer. Let's give him a warm applause.
Hello, everybody. Today we're going to talk about CodeTracer, which is a new way to debug Ruby programs. So what are we going to talk about today? First off, we are going to explain to you what a time travel debugger is and show you a quick demo of how it works. Then we are going to go through some technical details about how exactly it functions behind the scenes. And then we are going to continue with the history of the project, what is to be done. And in the end, we are going to talk a bit about how you can contribute to our open source project. And before we continue, however, there are some things that Stanislav wants to ask from you.
Hi, everyone. So, just change the slide.
Oh, yep, of course.
So I have a question for you all. How do you feel when you're debugging? Do you sometimes feel sad that you can't deal with a bug in time? Do you feel disappointed in your skills? Or do you feel like you're disappointed in the entire environment that you're programming in? Do you feel angry at yourself, your colleagues, the operating system that you use, or the technologies? Do you debug for so long that you're desperate to find a solution? So desperate, in fact, that you want to try reinstalling your operating system just to see if that will fix the issue? Do you, after debugging for so long, experience a state where you think that you've become mentally insane? Do you hear voices in your head?
Maybe sometimes.
As Gen Z developers say, bugs low-key PMO slime Furio. Furio gang. Well, what if we say that we might have a solution to this issue? Or at least a partial one? What if I say that you no longer have to deal with those emotions again? Introducing CodeTracer.
So, what is CodeTracer? CodeTracer is a time-traveling debugger that records the execution of a program into a self-contained trace file. You can think of the trace file like a video recording of your program. You can skip ahead, rewind backwards, jump to any moment of the program's execution, and rewatch the program execution as many times as you need in order to find a bug. So, before we continue about explaining about CodeTracer. Oh man, this is a side effect of switching screens. Just a moment. Oh man.
The Linux desktop is an interesting kernel.
Okay, so what are we seeing here? As you would expect from any debugger, we can jump forwards in code, we can add breakpoints, and of course we can navigate to those breakpoints. at will. But what's interesting about CodeTracer is that we can do every of those steps in reverse. So we can jump backwards to a previous breakpoint, or navigate backwards to to a previous line of code. Here in the top right part of the screen, we see what we call a code trace. The code trace is essentially a list of every function call that is going to happen throughout the code's execution. And if we collapse the two functions here in the top level, we can see that this corresponds to the code that we see. We have in this simple test program 2 test cases. We call the iterate asteroids function 2 times, and this is what we see in the code trace. So we can use this code trace to navigate easily to each of those function calls. And now that we're in the iterate asteroids function, we can see the next feature of CodeTracer, which is its omniscient loop controls. So here we have a loop, and we can easily navigate through each step of the loop. And of course, this works in reverse as well. And not only that, but let me zoom in a bit. We see the values of each variable in line. So as I move the slider, we see all the values update according to what has happened in the program's execution. And if you pay close attention to the bottom right part of the screen, we see that actually there's something reacting to those jumps. And this is what we call the event log. The event log is basically a list of every of your program's interactions with the outside world. So everything that is non-deterministic, that somehow may return an error or have some unpredictable outcome, like, for example, network events, file events, errors, stream events, or whatever. Everything that is not deterministic is recorded, and a snapshot is taken of the program at that moment, so that we can reconstruct the history of what will or has happened in a precisely the same way each time. What else do we see on the screen? So here in the top part of the screen, we see the state panel. The state panel essentially gives us an overview of what the current line of code has access to in terms of local variables. So here we see a list of all the local variables that line 15 will have access to. But not only that, but because CodeTracer is omniscient, we can also see the history of each variable. So, for example, the damage variable was initially not assigned, then it got a 0 assigned to it, then it got a minus 20,000 assigned to it, and so on. Another cool thing that we can show today is the trace log, and this actually allows you to inject code into your recorded program as you're debugging. So, for example, I can achieve the same thing as before with the variable history by just logging the damage variable. And now we see a list of every instance where of every time when the program passed through this line of code, what exactly the value was of this variable. But we can do more with this. We can also, for example, log the iterator as well. And this will allow us to better visualize what exactly is going on. Because now, as we see, here we have the iteration equals to 0. This means that we went through a second time through this function, and this helps you pinpoint issues more easily. Another cool feature that we have is the scratchpad, which allows you to set some variables aside to look at them at a later time. For example, this is very useful when you have some objects with a lot of properties and you just are interested in some small part of it and you want to compare two things, but you have to navigate to get those different things. So this is one of those features, and in the future, CodeTracer will have the ability to load a multitude of projects at once, and this feature will become even more useful when this happens. So this is cool and all, but how do we, how would we use this debugger in a normal debugging session, for example? And for this, I have prepared a very simple program. It's called Spaceship. And this is something very simplistic. You might include this, for example, in your video game, just as a small part of your game. Here in the example, we have a spaceship with a space shield, and it's passing through an asteroid field. And some collisions are inevitable, and we have to see if the spaceship will survive or not. And there's a catch: the shields get exponentially less efficient as the more drained the shields are. So at 50% shields, an asteroid would do 50 times more damage. Okay, with that aside, let's see what this example does. Here we have all the two arrays with the positive and negative test case. And right off the bat, without even navigating any further into the project, we can see from the event log that something fishy is happening. So, for example, here the damage, the first instance of damage is 0, but we don't have an asteroid with 0 mass. So at least some damage should happen. And if in CodeTracer, when you see something suspicious, you just click on it. And this leads us to the status report function. And in many projects, we have a situation just like that. The reporting happens not where the bugs are, but CodeTracer is a time travel debugger. And luckily, we can simply step back into where the actual problem lies. And now, when we take a look again at this loop, we can see that indeed the calculate damage function returned 0. So we just step into the function, and now, just 1 second, I accidentally moved to the next iteration. And now we can see exactly what's happening. So maybe some of you already see the issue. The mass is 100, the remaining shield is 100, and here in the calculation we multiply the mass by 100 minus the remaining shield, which in this case would be 0. So somebody forgot to place an if statement there so that the first calculation would pass. Spoiler alert, that was me. So okay, so there's something else bothersome in the event log that we can see, and this is that in the next iterations, the damage becomes a negative number. So let's see why this is. We can step back again in the same manner, and now we're in the second iteration of the loop, and indeed we see that the damage is minus 20,000. Okay. Let's jump back to this line. And now we are again in the calculate damage function, but now from the second iteration of the loop. And here we can see that the same calculation returns a weird number again, because the shield has surpassed 100% during the execution. So now a developer like me would say, okay, I know what's wrong, let's fix it. And through the power of editing, I'll just load up the next iteration of this presentation, where we have fixed just those issues. Okay, now, so the damage, as you can see, the first time is just as we expected. At 100% shields, the damage should be 100 for the first asteroid. Great. But if we scroll down a bit, we see that in the final result, the test had failed. So we expected the ship to be destroyed in the second, the negative test case, but it survived. And just from the logs, it's not immediately obvious why this is. So in those situations, it's very helpful to have something like a variable history. So let's navigate again to the function where the magic happens. And I could, for example, take a look at the all the different values here. So in the damage, I don't see anything suspicious. Let's take a look at the remaining shields, and nothing too suspicious here either. Maybe the origination? No? Okay. Now that we don't know how to continue, we can do something else. We can log several of the variables at once and see what this brings us as new information. So I'm going to log the damage again, the remaining shield, and the regeneration maybe. And now we can see, when we go through this, that actually there's a point in time where the remaining shield is minus 670. And this wasn't really obvious from the logs here, nor from the state panel, but we had a way to log it. And this didn't require me to go back into the project, to add a control log, to rebuild it again, to launch it again. It just happens inside of the debugging session. And now I see a problem and I have no idea how to fix it. But I know a colleague of mine who has the answer. I know he's very smart, he can fix anything in this world. So what do? I can restart CodeTracer, and the last recording of that we did of the program is the first one here in the recent traces. So we can upload this trace, copy the link from it, and I'm going to run a command to delete all the traces from my computer. So 1 second, just clear local traces. And now if I run CodeTracer again, we see that we don't have anything recorded yet, but I have the link to download the online trace. This, for example, happens on his computer, on my colleague's computer who knows everything, and he just pastes the link in, presses download, and voila, he has a copy of the bug reproduced without any further setup time and so on. So this was a quick demo of CodeTracer.
Just to add, before starting with the history of the project, I recommend you look at the presentation again, and maybe when the video is released, and try to think at any point of the presentation, try to think of all the possibilities of fixing bugs faster you can think of. I'm telling you, there's a lot of superpowers that CodeTracer gives you. Anyway, starting with the history of the project, it started in 2017. It was started by Zakhary Karadjov and Alexander Ivanov. They are a big... Zakhary is a big contributor to the NIM project, if you know the NIM programming language, and Alexander is a big fan of the Ruby programming language, so of course one of the first languages that CodeTracer supports is of course Ruby. And after a number of experimental implementations where they were the only two developers on the team, from 2017 to 2021, they figured out some concrete goals for the actual implementation of the real CodeTracer product. And since 2022, the team has gotten larger. Franz is, I think, from 2022. I started last year in September, and we have 2 more colleagues that started in the beginning of October last year. So we are growing quite fast. And we also released our first public release this March, and we have 2 more releases online since then. So you can look at our GitHub. In the next slides we'll have a link, and you can try downloading the release. And this is our progress. For those who play Clash of Clans, we started with Town Hall 1 and we are at Town Hall 9 in 2025. But given the growth of our team, I think we'll be at level 19 in less than 2 years. Anyway, our current roadmap is like this. In the short term, we are improving the backend for the scripting languages. Actually, CodeTracer is not just a debugger for Ruby. CodeTracer has 2 major backends. One backend is for scripting languages, which is based on a database. And the other one is based on the popular time-traveling RR debugger. This is for system programming languages. This includes languages like C, C++, Go, NIM, Rust, and more. And we are planning on improving this backend with some quality of life improvements, including improvements to the connective layer between the different languages we support. We also plan on improving CodeTracer generally. We are improving multi-platform support. Currently, we only support Linux and macOS. However, we have a person right now whose sole job is working on the Windows support, so we'll have Windows support really soon. And of course, we are listening to any feedback you can give to us. We have a number of links in the following slides. In the long term, we plan on adding support for more languages. This includes the system programming language backend. We're also planning on shipping extensions to code editors so that you don't have to use the normal CodeTracer GUI. You can just use it in Emacs or Vim or VS Code. We are also adding an integration with the debugger adapter protocol, which will allow us to easily create even more plugins for even more text editors. Finally, we are adding IDE-like functionality because we have clients that develop niche programming languages and they want to use CodeTracer both as a debugger for their language and as an IDE. And on top of that, we are adding WASM support. We are currently researching this step, but we expect for it to be done either by the end of this year or maybe by the end of next year. This is two-faceted. First, we're going to be adding WASM support for recording and replaying WASM applications, specifically in the stylus environment for smart contracts. And we are also going to add WASM support for the entire CodeTracer application so that you can launch CodeTracer for smaller projects directly in your web browser.
So before we continue on how you can contribute some words, of course, we showed you only the stuff that works. CodeTracer is not currently suited for big projects, and this is due to a lot of inefficiencies in the Ruby trace API and in the Ruby interpreter as well. And what we need to fix those issues is just to spend some time on them, to patch the Ruby trace API or even to patch the Ruby interpreter. So this is why we need your help. Since CodeTracer can be expanded very rapidly in all sorts of different fields, it's very hard to focus our attention on something. And what we need right now is a sign that the community is interested, because we have capable developers in our team, and we add functionality very quickly. Actually, as they said before, the first time I encountered Ruby was last year on this very conference when I was part on the filming crew, and only 2 months later we added Ruby support, and adding Ruby support took us only about 2 months. So there's a lot to be corrected, there's a lot to be done, but you can try it out as it's now. It works better for smaller projects, and Stan will explain you how to from where to get it.
By the way, we expect meeting you next year at the same presentation to talk about all the changes between that time. Anyway, here are the links to our source code. If you find anyone that is interested in maybe looking through the low-level details of how CodeTracer is implemented, specifically the Ruby backend, you can look at the CodeTracer Ruby recorder, which is actually a really small application, so it's quite easy to learn and understand. It's quite rudimentary at the moment, but we expect for it to get better and more performant in the near future. We also have documentation. This is actually partly my effort. We are documenting the entire CodeTracer application and everything about it, so that anyone can learn how to add their own language if they wish to, or if they just want to learn how to develop for CodeTracer. As a side note, we also have an open collective, and people who donate to the Open Collective can get early access to the RRGDB backend. So for those of you who are multilingual and want to access those system languages before they're actually released, you can maybe donate. But also we want to mention, why are these languages not supported as of now? It turns out that the RR backend is really hard to implement due to some limitations. So it will take us more time to implement the full scope of features that will be that are currently in CodeTracer for languages like Ruby. And we have some frequently asked questions that we will leave after on the screen after we finish the presentation. Well, as I said, we support Linux and macOS, but Windows is coming very soon. If you're working for a company or one of your friends is looking to invest in a project like this, maybe you can tell them to email us if they are interested in either supporting Ruby or adding another programming language to CodeTracer. We also have a Discord server where you can give feedback on everything you want to give feedback on. And you can download CodeTracer from our GitHub repo. We have links in the README for both macOS and Linux. People of Arch Linux, Gentoo, Red Hat-based distributions, and Ubuntu have package repositories that will be live in a couple of weeks. And for everyone else, you can just download the source code and compile it from scratch. Any questions?
Well, thank you for your attention, and hope to see you soon or next year.